Hey, this is OXDF, and today we're doing day 18 of the 2023 Advent of Code Lavaduct Lagoon. Um, basically, we're going to get a bunch of lines. Each line is going to have a direction, a number of spaces, and a color. And so basically, we're going to move. If we start at we're going to start up at the top left, basically. And so we're going to move right 6 spaces. This goes over here, and then we're going to go down 5, left 2, down 2. So that's left 2, down 2. And so we're gonna plow out this polygon. And I think it says somewhere around here that it will. Okay, well, yeah. So we're gonna plow this polygon. Then we're gonna dig out the interior of the polygon as well. So we're gonna get we'll get that, and we need to know the area of the dugout space. This is actually incredibly challenging. So there's a couple. My initial thought when I saw seeing this problem is like we can create a grid, map out all the spaces that are done, and then we could do like ray finding kind of things like we did in day, I think it was 10, to figure out what's on the inside and outside and count them up. Knowing Advent of Code, there's no way that part 2 is going to allow us to do that. They're going to find some way to make it, we're going to multiply this by 1,000 or something, or by 10 million, right? It's going to scale in such a way that we can't just check every point. It's going to be unscalable. So I've been reading Wikipedia and Stack Overflow and Stack Exchange and different things for a while now, and I've got a couple things I think are going to be useful here. Playing with this a little bit. First is Shoelace formula, which is going to allow us to take a series of points and get the area inside. And that is all we have to do is basically this right here. Area equals the sum of y1 plus y2, or the first of y plus the next y, x minus the next x, and divided by 2. And so we're going to use that to get the area. And then that's going to throw us a challenge in the fact that that is the internal area, and we actually want to count the spaces. We're not going to have any diagonal lines, so it's going to be a little weird, but we're going to have corners and things, and we need to count. It's going to effectively like cut off half of each square. I guess I could try to draw, but basically, if we're going, is there a square? Any example here with a not really. So it's not going to be quite right. We're going to have to do is use Pick's theorem here, which is to calculate we're going to get the internal area, which is actually the same area we get here. But then we can put it in terms of internal spaces, the number of spaces on the inside, and the number of border spaces. And by having those two things, now we're speaking the language we need for this problem, right? If we can take area and convert it to I and B, we can solve for what we're actually looking for is the sum of I plus B, because it'll be the number of internal spaces plus the number of border spaces. So with that, let's jump over here and take a look. We'll grab this as well and jump over here. I'll use Genday 18 to pull my inputs and create a stub. There's a link in the repo if you want to go check out that script, and I will create example.txt. Put it in here. That does not look like what I wanted. I don't want that. I want this. Great. Sweet. So let's go ahead and figure this out. So the first thing part's probably pretty easy actually. We've got our lines. We will do, let's say points is equal to a list. We'll say r comma c equals 0 comma 0 to give ourselves a starting place. So now we can say for line in lines, dn, and we don't use the last part, equals line dot split, like that. We'll say dr dc is equal to, and well, actually let's come up here, dir map equals, and we're just going to real quickly here. So if we're going right, we're going to go 0 comma 1. If we're going left, we're going to go 0 comma negative 1. We're going up, we're going to go 0 comma negative, negative 1 comma 0. And if we're going down, we're going to go 1, comma 0. So now we can say drdc equals dir map of d. And now we can say r plus equals dr times n times int n. C plus equals dc times int n. And now we can do points dot append r comma c. And that should give us a list of points. We can take a look at this. Points. We should also add 0, comma 0 in there. We're going to start there. And now if we do Python day 18 example.txt, dir map not call. I'm doing that a lot lately. Let's see. So we got our series of points. We could look at the example to the side. We can go right 6, down 5, left 2. This is looking good. Down 2, right 2, down 2, left 5. So from 6 to 1. Yep. So this is, I think we're looking pretty good here. We'll note we do start and end at the same point. So that's good. That's useful. I wonder if we can assume that. Let's see. What if we do? I guess we can try this real quick on input. We do end back at 0, 0. So we can that's really useful to know, because now we don't need to. We know we could generalize, of course, and make it so it's not the case. They tell us in the example. Let's see. Because we're going to need both perimeter and area. This is a good time to test our perimeter function, because they tell us that the trench could contain 38. So let's go up here and we will do def per. Let's spell perimeter. Is that right? We're gonna go with it. I hope it's right. Maybe I'll fix it if I post it. Let's see. So the perimeter is going to be. We just need to step through all the spaces, right? So we'll say total equals 0, and I might make this into a list comprehension, but we'll see for R1 C1, R2 C2. So we're gonna, for any pair of points in zip, and we'll say points. And so what are we gonna do? We want to get every point with its next point. So we're gonna say points sub 1 like that. So we're gonna take the first point. This will offset it by 1, and then we want to add the other point back to the end. So we can say points sub 0. So this is basically just going to be taking the first point and putting it at last, and now we can give ourselves a circle. I think because, yeah, that'll work. Yeah, that's fine. So for that thing, we're going to just say total equals abs, because we know we're only ever moving up. We're only moving up or down. We're never moving diagonally. So we can just do abs of R1 minus R2 plus abs of C1 minus C2. And now we return total. We can try this. We can say total perimeter of points. Hopefully we get 38. We don't get, takes 1, 0 positional argument. We should add in points here. We got 0. Something is not right there clearly. Points. So we are going to. Oh wait, hold on. R1 minus R1 does not look good. Let's put space there too. Let's try this. Still 0. R1 minus R2, C1 minus C2. We are happy with our points being good. Let's go up here and debug. I've got a video on several days ago about setting this up in VS Code. So here, let's see our total. Up to 6. Up to 5. How did our total go down? Because I'm saying it equals. Okay. There we go. We found the error. Let's try this again. 38. We got the answer we're looking for. Okay, so now we'll go back to Shoelace. I'm going to move this off the screen so I can see it, and you can pull it up, obviously. What we want here is def internal area points, and this is going to be the sums. We'll do another total equals 0. And then I guess bright light, bright light off my face. Let's see. Total equals 0. Now we can say for same loop here. We're going to loop through our points. And this time we're going to say total plus equals R1 plus R2 times C1 minus C2. And we are going to return total over 2. So if we run this, we'll see, space there. We're going to say internal area points, and we're going to get unfortunately not the answer, 42. So this is where we get to do some math. So we know we know Shoelace gives us the internal area. Pick's theorem tells us the internal area plus, the area is equal to the number of internal spaces plus b over 2 minus 1, where b is the number of border spaces. So if we come down here and we'll do this by math. We know A, which is that area we've got here, is equal to the number of internal spaces plus b over 2 minus 1. And we want to show that we need to get the number of total spaces. So that's going to be the internal spaces plus the number of plus b. So we can solve this. We can say I is equal to a minus b over 2 plus 1. We subtracted b over 2 and negative 1 from both sides. And then we can say I plus b is equal to a plus b over 2, because b minus b over 2 plus b is that, plus 1. And that's going to be our answer. So this is our a right here. When b over 2 is going to be the perimeter divided by 2. So we can do perimeter points divided by 2 and with plus 1. If we run that, we get 62, which is the answer. So let's see, we run this on input.text, we get a number, we got a star. Sweet. Part 2, I'll pause and read this. All right, so I feel vindicated. Dude, you do enough advent of code, you start to figure out where they're going to go with it. We're going to now basically ignore these R's and D's. They're not relevant. What we're going to do is work with these hexadecimal values. And for each one of them, the first 5 digits, in this case, like 70 through 70C71, is a hexadecimal number of n, what we called n. And then the last number is going to be 0 through 3. And that's going to map over to R, D, L, and U. And so we're going to basically ignore the R, D, L, and U, and we're going to just use these. We will, I guess for the sake of, let's see, we're going to do, this is a trick. I always feel like this is important. If we're going to copy code, which we're going to do here, we're going to grab this, come down here, do this. We want to comment out part 1 just to make our changes very easy to do. So this will become points 2, which means we need points 2 here, and I think otherwise we are good. Okay. We can even do, I believe we can even do this the same. This will be points 2. All right. That's good. We can uncomment you. So now what are we going to do? We're going to do the same thing, except for now we're going to say underscore hex string equals line.split. We're going to say n equals int. We better do some split. We should say, let's see, hex string equals hex string dot strip. And what do we want to get rid of? We need to get rid of the pound and the slashes. The pound and the hashes, I believe. We can double check that. Yeah, so we need to get rid of any of those characters. So that's fine. That'll be good. Now we're going to say n equals int hex string 0 to the first 5 digits, 0, 1, 2, 3. I think that'll look good. And then we are going to say dr dc equals, and what are we going to do here? So we said from the problem, rdlu. I think we can do this. rdlu like this. Sub int hex string 5. So we're going to take the last hex string, we're going to turn it into an integer. We're then going to turn that into a indices into this string, which will give us that. So now we just need dir map on that. And I think we're good here. Let's run this. I'm sure we're going to hit some sort of snag. Here we go. We're not doing int 10, we're doing base 16. We got an answer. This is for the example. The example answer is huge. Let's see, is that right? Whoa, okay, that looks very good. We got it. Okay, so we're gonna run this on input. Nailed it. Sweet. All right, this problem, once the hard part is knowing the math. The easy part, this parsing stuff is pretty trivial. Like, this could be a day one problem once we know the math. The challenge is going to be finding these two algorithms, because there's like I said in the intro, there's no way we could have done just tracking points to get that many points. That is a lot of points. So I learned 2 new algorithms today: Shoelace and or picks, and I'll put those in the description as well, so you have access to them, and probably put them as comments in the code as well. Thanks for hanging out with me today. I'll be back tomorrow with another one. Bye.